Often on the GRE, we need a quick way to compare the size of two fractions. Sometimes a QC question will ask us to compare them directly, and other times comparing them will be part of a larger problem. So some of the basic ideas here: if we keep the same denominator, then making the numerator bigger makes the whole fraction bigger. And so if A is a larger number than B, then as long as we're dealing with everything positive here, then A over C is going to be bigger than B over C. So for example, here are fractions that are paired. They have the same denominator. So 4 over 16 has to be less than 6 over 13. 5 over 50, of course, has to be greater than 0 over 50, which is just 0. And 8 over 3 has to be bigger than has to be smaller than 14 over 3. And you can think of this in terms of ordinary things. If there are 8 cookies that are going to be divided by 3 children, well, they're going to get less in the amount of total number of cookies than the case where they have to divide 14 cookies. If there's 14 cookies divided among the same 3 children, then each child is going to get more in terms of cookies. So that's a greater amount. What if we change the denominator and keep the numerator the same? Well, if we make everything positive here, then if we make the denominator bigger, we get a smaller fraction. This is a really big, really important idea. Make the denominator bigger, we get a smaller fraction. So for example, 2/5 is greater than 2/7. When we make the denominator bigger, the fraction gets smaller. 3/11 is less than 3/10, and 7/24 is greater than 7/36. And again, think of it in terms of ordinary sharing. If we have 2 apple pies and we're going to split it among 5 people, well then each person is going to get a lot of pie. But instead, if we take those 2 pies and we split it among 7 people, well then each person is going to get a little less in terms of pie than when there were just 5 people. Again, think of ordinary sharing scenarios that will help you make sense of these rules with fractions. What if we change both the numerator and the denominator? Well, if we change the numerator and the denominator, we can do that in a few different ways. If both the denominator gets bigger and the numerator gets bigger and the denominator gets smaller, then the fraction definitely gets bigger. So for example, we start with 3/8 and we go to 4/7, bigger numerator and smaller denominator. So we started out sharing 3 pies among 8 people, and then instead we were sharing 4 pies among 7 people. Well, definitely everyone's going to get more pie. Another way that we could increase is multiply them both. And of course, if we multiply numerator and denominator by the same number, we get an equivalent fraction, as we've discussed already. So for example, 3 over 7, if we multiply numerator and denominator by 12, we get 36 over 84. Those two are 100% mathematically equal. They have exactly the same value. Before we're talking about another comparison technique, we have to talk about the very handy technique of cross multiplication. We use cross multiplication when we have an equation of the form fraction equals fraction. Such an equation is called a proportion, and we will discuss these in more depth in the lesson Operations with Proportions. Here we're just going to talk about cross multiplication. If we start with one of these equations, so A over B equals C over D, we can eliminate all fractions simply by multiplying each denominator by the numerator on the other side. So when we cross multiply, we're multiplying these two together and multiplying these two together. And the fact that those two ovals are crossing, that's why it's called cross multiplication. So we wind up with A times D equals B times C. So every numerator stays on its own side, and the numerator from the other side multiplies it. The denominator from the other side multiplies it. Now that we talked about cross multiplication, we can talk about another completely different trick for comparing two fractions, a trick that uses cross multiplication. Suppose in a problem we had to compare the size of 7 over 11 and 5 over 8, two relatively close fractions, and decide which one is bigger. I mean, yes, we could use the calculator, write down the decimals, but that would be time consuming, and we'd have to write down a lot of the decimal to see what the difference is. Instead, write the fractions with a double question mark sign between them. This double question mark, it's sort of an unknown for the relationship between them, and it could represent either greater than or less than. So we have 7 over 11, double question mark, 5 over 8. And we know there's an inequality between them. Now, we get in trouble if we multiply or divide by a negative, but fortunately everything here is positive. So multiplying by positive numbers and even cross-multiplying is not going to change that inequality at all. So we just cross-multiply. We get 7 times 8 and 5 times 11, so that's 56 on the left and 55 on the right. Well, now we know 56 is bigger than 55. We did nothing to change the direction of the inequality. So, in fact, 7 over 11 is bigger than 5 over 8. And we found this with cross-multiplication. Here's another example. Pause the video and see if you can figure this out yourself. Okay, again, we're going to cross-multiply, which will not change the direction of the inequality. And, of course, 9 times 9 is 81. 20 times 4 is 80. 81 is greater than 80. So that means that 9 over 20 is greater than 4 over 9. A final comparison trick is one that involves number sense. And it's about recognizing when a big, ugly fraction is close to a nice fraction. So, for example, suppose we look at this fraction here. Well, that fraction it has to be greater than 80 over 240. But 80 over 240, that's a nice fraction. That's just 1/3. So this fraction, 83 over 240, is slightly larger than 1/3. Well, that's interesting. Suppose we compare it to this fraction, 199 over 601. Well, 199 over 601, that's very close to 200 over 600. But, of course, if we make the numerator bigger and the denominator smaller, 200 over 600 is going to be slightly larger. And 200 and 600 also equals 1/3. And so we know that 83 over 240 is greater than 1/3. 199 over 601 is less than 1/3. And so right away, that tells us that the one that's greater than 1/3 has to be greater than the one that is less than the third. And so this makes it easy to compare ugly fractions if we can use number sense to see that they're actually very close to a nice, neat fraction. Here's a practice question. Pause the video and then we'll talk about this. The number sense that we're going to use here to compare these fractions is the fact that both of these are relatively close to 3. We know that 3 equals 21 over 7. And 3 also equals 450 over 150. So those are exactly equal to 3. Here, we can express each one of these as the fraction that equals 3 minus something. So, of course, 449 over 150, that equals 450 over 150 minus 1 over 150. And 20 over 7, that equals 21 over 7 minus 1 over 7. And just to make it easier, since this fraction and this fraction equal 3, I'm just going to replace them with 3. So it's very easy to see. Well, of course, look at what we're subtracting. Clearly, 1 over 150 is much less than 1 over 7. And so if we're subtracting something bigger, start from the same place, subtract something bigger, we go down more. Subtract something smaller, we go down less. And so the bigger one here has to be the one where we're subtracting the smaller quantity, which is answer choice A. So we talked about a lot in this video. We talked about with the same denominator, bigger numerator means a bigger fraction. With the same numerator, a bigger denominator means a smaller fraction. If you're dividing by more, you get a smaller fraction. And then, of course, you can combine 1 and 2. If you get a bigger numerator and a smaller denominator, then you're definitely going to be bigger, that sort of thing. We talked about equivalent fractions. We talked about cross multiplication as a means of comparison. And then we talked about number sense comparisons.